Now after seeing all these layers, it must be too confusing for you. How are all these layers going to work together, and how are they going to help us in sending a message from source to destination? So in this example, I'll take an example and I'll explain you how all the layers are going to work together in order to send a message from source to destination. I'll just take this example and I'll show you. Watch it closely. Now let us assume that there is a source here, and a source wants to send a message to some machine. So let us say it is your computer, and you want to contact Google, right? And there are two cases. One case is that Google is going to be directly in your message. Let us say your IP address is IA, and you want to contact Google. You want to get that Google web page, right? And now what are the various ways you could contact it is, one thing is, first you should get the IP address of Google. How can you given the domain name, that google.com, how can you convert it to IP address? I told you in the initial class that the first lecture, that there is some concept called as DNS. DNS is going to convert this domain name to IP address. Let us say you know that the IP address of Google is IG. Your IP address is IA and Google's IP address is IG. Now there are two cases. One thing is your machine and Google A as well as Google are both present in the same network, and the other case is your machine and Google are both present in different networks, which means in this case, if you are both present in the same network, you need not go to the router, right? You can directly contact the Google and Google will send you whatever you require. But here, in case if you are present in another network separately from Google, then you are supposed to send the message to the router, and router is supposed to send it to the Google, and then Google will reply, and then you will get it, right? So both the cases are actually different in the sense, when one case you are directly contacting Google, in other case you are contacting the router. So what is the case in which you should send the packet to router, and what is the case in which you could directly contact the Google is, that depends on where you are present in. So how will the source host A, how will it know that Google is present in the same network, and how will it know that Google is present in the different network? For that we are going to use the concept of subnet mask. Let us say subnet mask of A is SA, right? Then what happens is the source A will AND its IP address with subnet mask A. Then it will get network ID of A according to A, and it will take the IP address of G and AND it with the subnet mask of A. Then it will get network ID of Google according to A. If these two are equal, then it means that according to A, both the A and Google are in the same network. In that case, A is directly going to contact Google. In case if these two are not equal, it means that both A and Google are present in different networks. In that case, A is going to send the message to router, and router is going to forward it to the Google. There could be any number of routers on the way. But anyways, this is the concept. So how can you find out a host is in the same network or not? We are simply going to use the subnet mask and the IP addresses, right? Now let us assume that Google is in a different network. Then I want to tell you what are the set of messages that will be exchanged between the source and the router and the Google, right? I'll just take a network example and I'll show you how the message will actually go through all the layers and this network, right? Now I'll take a small example and I'll explain you how the message goes through all the layers to the destination, or how all these layers are actually working in order to get your message from the source to destination. Just see this example once. You could zoom in, okay? So let us say all the layers are like this: physical layer, data link layer. I need the entire board. It is a big example. Physical layer, data link layer, network layer, transport layer, and application layer. Let us say you are at a host A. This is a host A, and host A wants to send a message to Google, and assume that Google is not in the same network, and A knows that Google is not in the same network, and it has to send it over the routers. A knows it. How? By using the subnet mask. I have already told you that, right? And assume that every network, A is present in a network, and every network is going to have a default router or default gateway, and this is the default gateway for A. This is default gateway or router for A, right? And now message starts from application layer. So from application layer, message starts, and that will be given to transport layer. So transport layer is going to add many things to the header of this message, which means transport layer will take the message from application layer and is going to add a header. In the header there are many important things, but what I will be mainly worried about is at the transport layer, the port numbers. The reason is transport layer is responsible for end-to-end communication, and in order to identify the ends we need the port numbers. Assume that this is source port number. Source port number is X and Google's destination port number is 80, which means X and 80. Now this message will be given to network layer. Network layer is going to take this MX80 and it is going to add a header. So in the header there are many things which are going to be added, but the most important things are IP addresses, right? The reason is a network layer is responsible for host to host connectivity, and every host is uniquely identified by IP address. Let us assume this IP address of A is IA. Therefore source IP address is IA, and let us say destination IP address is IG. How do you know the destination IP address? By using the DNS. I already told you, right? And now this one is going to be given to data link layer. So data link layer is going to get message, this entire thing, and it is also going to add a header, right? So in the data link layer header there are many things, but then the most important things that we have seen in data link layer frame is physical addresses. Physical address means it is used to go for hop to hop, which means we not to communicate within one network, then physical addresses are going to be useful. So network layer is from host to host, that is by IP addresses, and transport layer is end to end, that is by port numbers, and physical data link layer is hop to hop or communication within one network, within a single network, and the numbers which are going to be useful in a single network are physical addresses, right? So for physical address, let us assume that this is a network kind of Ethernet, and the physical address used is MAC addresses, MA, right? Let us say this is the router here, and router's IP address is, let us assume that IR1, and router's MAC address is MR1, right? So what is the source MAC address? The packet is coming from A, therefore source MAC address is MA. And what is the destination MAC address? So are you supposed to send the packet to Google? You found out that Google is not there in our network, therefore you cannot directly send a packet to Google. You have to send the packet to the router. Therefore here, as the destination MAC address, you should not put the Google's MAC address, you should put the router's MAC address, right? So in your computer, if you look at that IP config or if config, I told you that you will find out what your IP address is, then you will find out what your MAC address is. Along with this, ISP is also going to give you DNS IP address. You need the DNS in order to get the IP address of the destination. Along with that, you are also going to see something called as this destination or default gateway. The default gateway is also default router, and this is the router what it is. So you have the IP address of this default router or default gateway already provided by your ISP, which is already there in your computer. Therefore, as a host A, you know the IP address of this router, but then you want the MAC address of the router. The reason is we cannot send a frame without the MAC addresses. So given this IP address of the router, so I have the IP address of router which is IR1. Now I want to find out MAC address which is MR1, right? I want to convert the IP address to MAC. So for this I use the protocol ARP, address resolution protocol. So address resolution protocol is useful to take the IP address and then convert it to MAC address, right? So what we need is, we have the IP address of router. Now I want to find out the MAC address of the router. Therefore, for that procedure, before sending anything, host A is going to send something called as ARP request. This ARP request will be seen by everyone in the network. Everyone will listen to this, and in this ARP request we are actually asking, I know the IP address of router, but I don't know the MAC address of router, please send me the MAC address of the router, right? It is like this. ARP, how we could think of ARP is, let us assume that in a classroom I know the name of a person, but I don't know who he is, the physical person. I know the name of the person. Let us say his name is Satish. Then what I do is I get into the class and then I shout with his name, who is Satish? Then Satish will raise up his hand and say, I am Satish. Similarly, ARP is also same thing, which means you are shouting that I know the IP address of a host is IR1, please tell me your MAC address, I want to send you a frame. Then everyone will listen, which means when I shout out the name Satish, everyone in the class will listen, isn't it? Similarly, ARP request also, everyone will listen. If you want to know more about ARP, there is a special topic, special video with the heading ARP. You can get into that and you can learn it. Okay, for now we just understand that there is a concept called as ARP, and when I shout using ARP, everyone will listen it and only the person with that particular IP address will reply, which means you are asking, see, I know the IP address of the router is IR1, I don't know your MAC address, please say. Then the router is going to say, yes, I am the IP address IR1 and this is my MAC address MR1. Therefore, you will now find out that the MAC address of router R1 is MR1. Then you are going to put it here. So what does it mean? You are going to you have to send the packet to Google, but then since the Google is not in your network, you are putting it in a frame and now the frame is sent to the router. That is the meaning of it. Now, physical layer is going to take this packet as it is. At data link layer, even the tail will be added, isn't it? There will be header and tail. Physical layer will take the packet as it is and it will convert it to bits and it will send it out. So before sending the actual packet, what happens is, one thing is DNS request will go on in order to find out the IP address of the destination. Second thing is ARP will go on in order to find out the MAC address of the destination. In case if the destination is in the same network, we send out the DNS to get the destination's MAC address. In case if the destination is not in the same network, we send out the ARP to get the MAC address of the router. Then we send the frame to the router, right? So now observe this. So this is going to be sent, and again this frame will be seen by everyone in the network, but then who has to take it is only the station who has the physical layer is going to add that start of the frame delimiter so that everyone will be alerted. When everyone is alerted, everyone will see it, but only the station who is supposed to read it is the station with the MAC address as MR1. Who is that? The router. Therefore, router will have physical layer, data link layer and network layer. So remember that a router will have only 3 layers. I'll discuss again this topic in a special topic called as routers, but for now understand that router will have only 3 layers, not all the layers, they are not required, right? So physical layer will look at this packet and it will alert data link layer. Data link layer will look at this address and understand that, oh, this packet is for me because this packet is directed for MR1, which means this packet is for me, and therefore it will accept it. And as well as, okay, before going ahead, let me again one more time tell you what these numbers are. See, transport layer is going to add many things. Among them, the most important thing, this X is nothing but the source port number, and this 80 is nothing but the destination port number, right? And this network layer is going to add many things to whatever is given from transport layer. Most important thing is this one, right? So this is nothing but source IP address and this is nothing but destination IP address, right? Now how do you know the source port number? You are going to set the source port number randomly. X can be any random number and you can choose it your wish. And how do you know the destination port number? Generally destination port number is, I'll again talk about this in TCP at port numbers, but then for now understand that all the well-known ports, they have a well-known all the well-known this process, they have a port number which is well known. Like how can I tell you is, for police station we are going to have 100, isn't it? Okay, one second, he's disturbing me. For police station we are going to have the number 100, and for fire station we are going to have the number 101. Like that, this port number is fixed, it is well known, which means everyone knows it, no one need to tell you. And coming to this network layer, it is going to add source IP address and destination IP address. And how do you know the destination IP address? By using DNS. DNS is going to tell you the destination IP address, right? And now this is nothing but the source MAC address, and this is nothing but the destination MAC address, right? So this is well known, no one need to tell you. And for this we are going to use DNS, and for this we are going to use ARP. So DNS is used to find out this, and ARP is used to find out this, right? Okay, now with that knowledge, let's continue. Now who is going to take this? The router, because the destination MAC address is MR1, and the only station with MR1 as the destination address is router. Therefore router is going to take this entire frame, right? And then it will also say that okay, I got the frame and it is fine. So this data link layer from the router is going to send out an acknowledgement to this data link layer in a frame. Similarly, like this, it will create a frame, and from data link layer it will send out the frame saying that I got the frame, you don't worry, you can remove it. Therefore data link layer will take care of hop to hop delivery, which means when you are sending the packet, we are just saying that yes, I got it, like that, right? So data link layer takes care of hop to hop. For that it is going to use MAC addresses, right? And now data link layer will remove this header which is added by the data link layer of the other side, and from this inside datagram it will take it and give it to the network. Therefore network layer is going to get this. Network layer is going to get this entire datagram, and it will understand that oh, the packet has to be delivered to IG. Now what network layer will do is it will look at the destination IP address and will understand that the packet has to be delivered to a station with IP address IG, and it is not for him. So what is the IP address? What is the IP address of router is IR1, but here it is saying that I have to go to IG, which means the packet is definitely not for this. It has to be sent, it has to be forwarded, right? Therefore at this router it will have something called as routing table, and I told you that routing table will have 3 columns, right? So one column is destination network or network ID. You please go back to the topic of routing tables. One column is network ID, other column is subnet mask, and other column is interface. These are the 3 columns we have. Now what will this router do is, router will take this IP address and it will land it with the subnet mask. If the result matches with this, it will send it over the interface. In general, what happens is the routing table will contain one entry for every network this router is connected to. Let us say this router is connected to 2 networks, N1 and N2, right? Then it will check with the subnet mask if this packet belongs to this network or if this packet belongs to this network. Let us assume that this packet does not belong to any of the networks to which this router is connected to. Then what is this router supposed to do? It will use the default lost entry, default entry. The default entry is all zeros, right? So all zeros and all zeros. Let us say the default entry is this router. What does it mean? If this router knows where to send the packet, it will send it. If it doesn't know where to send the packet, or if it has got a packet which is not to a host which is not present in any of the networks it is connected to, it will choose one of the default routes and forward it. My assumption is that I am assuming that this router R1 is having a router R2 as the default entry, which means if it doesn't know where to send the packet, it will send it to R2. So what it will do is, it will take this entire packet, what does that entire packet contain? Message X80, IA and IG. It will take this entire packet and then it will give it to the data link layer. Now the data link layer will take it, message X80, IA, IG. One more thing, see this, even though now this packet is being delivered from R1, you should not change this source IP address as IR1. The reason is the packet is actually originating from A, therefore that information should be there. If you change IA, then the reply will never go to IA. If you change this address, then the receiver will never understand who the source is. Therefore, you are not supposed to change it, right? And coming to this IG, even though you are sending the packet to IR2, you should not change this one to IR2. The reason is, if you change it, the packet will stop at this point. It will never reach the destination. Therefore, IP addresses at the network layer should never be changed, should never be touched. Then what will be changed? Only the MAC addresses, isn't it? See this here. Now, data link layer is going to add a header. In that header, the main important things are MAC addresses. Even though the packet is coming from MA to MR1, now the actual sender has changed. Now the packet is coming from this MR1. Therefore, in the source MAC address, the MAC address is MR1, which means the packet is starting from the router R1 and the destination MAC address is MR2. Now, this router should know the MAC address of this router, but then we only know the IP address of the other host, not the MAC addresses in general, right? Then what will this router do is, it will shout, ARP shout. It will send a ARP request asking, see, I know your IP address, please send me your MAC address. Everyone in this network, if there are many stations connected, everyone in this network will listen to that, and they'll say, this router will say, yes, I am the station and my MAC address is MR1, MR2. Then what will this station do is, this router do is, it will change it to MR2. Right? Therefore, that is how the data link layer is going to fill up the MAC addresses. Now this one will be given to physical layer. Physical layer is going to take this and convert to bits, and it is going to send it out, right? So assume that the packet is delivered this way. So what are the only changes that have been undergone here is, one thing is IP addresses didn't change, they should not change, source or destination IP address. So what should change is the MAC addresses. Here the original MAC addresses are from MA to MR1, but now for the next hop the MAC address is MR1 to MR2. That is what has changed. Now this packet will be given to physical layer. Physical layer will convert it to bits and send it to the router. Now the packet will be reaching the router. Everyone in this network will see, and physical layer will alert the data link layer. Now data link layer will see the destination MAC address and will understand that, oh, this packet is for me. How will it understand it? Because the destination MAC address is clearly saying that it is to MR2 and it is the host with MR2. Therefore, it will take it. And now this data link layer, after receiving the packet, will send an acknowledgement from here to here. Therefore, data link layer is responsible for every hop. So after sending the packet one hop, if it is received, then you are supposed to send the acknowledgement. That is why I am saying that data link layer is hop to hop protocol. I mean, hop to hop will be taken care by data link layer, right? And now this data link layer is going to remove this header and give the packet to network layer. So network layer has got it. Network layer can look into this IP address and understand that the packet has to be sent to the host with IP address IG, and it knows that it is not my IP address. Therefore, it is supposed to forward the packet to the host. Let us assume this router is connected to the network in which actually Google is present finally, right? Then how will it identify it? Now it will have a routing table. In this routing table, it will have entries. Let us say this is the network, let us say N3, and this is subnet mask S3, and the interface is A. This interface is A. Then when it takes this IP address and with the subnet, then it matches with the network ID in case if the Google is present in this network. Our assumption is that Google is present in the network. Therefore, it ANDs it and it finds out that yes, the packet has to be sent to this network. Then what it will do is, it will take the packet, the same packet which contains message, port numbers, IA and IG, and it will give it to the data link layer. What should data link layer do? It should add the MAC addresses, right? So what do you need? You need the MAC address of Google finally, isn't it? So again, how do you get the MAC address given the IP address? How do you know the IP address? It is there in the packet, and you know that it is there in the network. So you know that there is a host present in the network and you want to deliver a message to that host. Therefore, you are going to shout saying that, see, I know that you are there in the network, and you got a packet. Please send me your MAC address. I'll send you the this frame with the whatever letter you got. So now again you are going to shout, this router is going to shout asking for the IP address, MAC address of Google. So MAC address of Google, let us say its IP address is IG and MAC address is MG. Then what Google is going to say is, yes, it is me and my MAC address is so and so. Therefore you got the MAC address of Google, right? And you are going to add here, yes, the packet is now from MR2 and the packet has to go to MG. So this is the source MAC address and this is the destination MAC address, right? Please just zoom in into this. And now this will be given to the physical layer. So physical layer is going to take this packet and put it on the wire, that link. Now Google is going to receive this packet, Google's physical layer. So physical layer will see this packet and alert the data link layer. Data link layer will see this packet and understand that, oh, this packet is for me. The reason is the MAC address is given as MG. Therefore it will send a acknowledgement from this data link layer to this data link layer. Data link layer will get the acknowledgement. And now at the destination, all the layers will be present, which means network layer will be present, transport layer will be present, as well as application layer will be present, right? Now data link layer is going to remove this MAC addresses and give the packet to network layer. Network layer will look at the IP addresses and understand that, oh, the packet is for me, the packet is IG. But then network layer is not going to send an acknowledgement from here to here. The reason is, I told you that in IP we are talking about TCP IP. I told you that in IP we are not going to have connection oriented, which means there are no acknowledgements. It is a connectionless datagram service. Therefore there will be no acknowledgement sent. Now this one will be given to transport layer. Now network layer will take this and it will understand that it is for it. It is going to remove the header. It will give it to the transport layer. So transport layer will get this. I told you that network layer, since it is datagram service, network layer will not send any acknowledgement. Now let's see what happens at transport layer. At transport layer, the message is coming from port number X and it has to be given to port number 80. What will transport layer understand is, oh, the packet has to be given to the process with port number 80. So what does it mean is, at application layer there will be many processes and every process will have a port number, and now it will understand that this packet has to be given to the process with port number 80, right? So it will take this and it will give the message to the process number 80. In case if it is TCP, which means if we are talking about TCP is a reliable service and it is a connection oriented service. So reliable connection oriented means there will be acknowledgements. So in that case what happens is, this transport layer is going to send an acknowledgement from end to end, which means from one end to the other end the transport layer is going to send the acknowledgements. So from that transport layer, acknowledgement will come from this transport layer. Is it coming magically like a Superman from there to there? No. Actually transport layer has to send the acknowledgement like just like how the data has come, which means acknowledgement will come from here to here, from here to here, here to here. So like this it should come back, right? Now how will the transport layer knows whom to send? So from the source port number it will calculate the destination port number, which means if the packet is coming from the port number X, then the packet has to go to port number X, and from the network layer it will understand this. If the packet is coming from the IP address IA, it has to go to the IP address IA. That is why you are not supposed to change IP address on the way, right? And MAC address is not required. Anyway, MAC address will be calculated by data link layer by using ARP only. So which means from here the packet will jump and go there, right? So some of the things you should understand here is, which are very important, is one thing is transport layer is responsible for end to end, network layer is responsible for host to host, and data link layer is responsible for hop to hop, which means everything that happens on one hop is taken care by data link layer, right? And next thing is, there is flow control between data link layers as well as transport layer. The reason is, see this, I'm talking about this router IR1. IR1 will be connected to many hosts, not just to host A. From all the packets coming from all the hosts, this router will collect them and it will put all the frames in one buffer, one window, and will send it to the are the destination, right? Which means this data link layer and this data link layer will be worrying about the number of packets that have to be sent between only these two routers. And at transport layer, what you will be worried about is between these two processes, whatever packets have to be sent, they all will be kept in one window, and that entire window will be sent at once. At transport layer, you will be worrying about that. At data link layer, you will be worrying about the other thing, right? So flow control is applied both at transport layer as well as data link layer. At data link layer, it is between two routers, and at transport layer, it is from end to end, right? So transport layer thinks about the capacity of the sender as well as receiver. That is why end-to-end flow control is applied. And data link layer thinks about the capacity of the router and router, which means one hop from sender to router, router to router, like this. So that takes care of this. And second thing is error control is also there both at transport layer and data link layer. At data link layer, we are worried about bit level errors, which means if I am sending a packet, whether some bits are corrupted in it or not. At transport layer, we are worried about bit level as well as packet level errors, which means sometimes what happens is, see, when you send a packet at the destination, this data link layer, if there is a bit level error, CRC will take care of it and it will know that yes, something has happened. But then because of some reason, if the entire packet is completely lost, which means you send the packet to this and it has sent out the acknowledgement, and before sending the packet to the next hop, this router is down, then what happens? Sender will think that, oh, I have delivered the packet, sending data link layer, and this data link layer will never receive it, and that data link layer will never receive it. No one will know that the packet is lost. That is why that will be handled at transport layer, right? And this acknowledgements is used only by TCP, not by UDP. So flow control, error control and acknowledgements are used by TCP, not by UDP. Again, we shall discuss it at TCP, right? So there are some functionalities which are taken care both by transport layer as well as data link layer, but remember that transport layer is end to end and data link layer is hop to hop, and network layer is host to host, right? And other thing which you might wonder here is, at data link layer we are always communicating with the MAC addresses, not with IP addresses, which means if you look at this, I am writing only the MAC address of the destination, not the IP address of the destination. Then in your host computer at your home, if you look at the default gateway or default router, they will give you the IP address of the default gateway or router, not the MAC address. Why do you think this is so? Generally we are using only the MAC address, but then in your computer they are directly going to give you only the IP address of the default gateway. They should have given you the MAC address, right? Why do you think that they are not giving the MAC address? The reason is router's IP address is going to be static. It is going to be fixed. The reason is ISP is having the router and ISP is having all the IP addresses. Therefore, one of the IP address will be allocated to the router forever. Therefore, IP address doesn't change for a router as frequently as possible. At least for 4-5 years it will not change. But then coming to MAC address, what happens is MAC address is present on the NIC, and with heavy load when you are sending lots of packets, there is a chance that NIC may get corrupted, or NIC may get worn out. Then what we should do is we should remove the NIC. Therefore, at router, MAC address will change constantly. The reason is the NIC has to be removed very frequently, but the IP address is going to be static and fixed. The reason is IP address with this ISP, and it is going to give you the IP address, right? So remember these 2 points. At a router, we are using the IP address, not the MAC address. Therefore, since the MAC address is temporary, given the IP address, you can find out what is the MAC address at that moment using ARP, right? So even though you are using MAC address, they are going to give you only IP address in your computer. Therefore, take the IP address and convert it to MAC address and then send it, right? So that is the next point. And one more interesting question here is, so if you understood all this, I told you that this router is going to have only 3 layers. So if you look at actually router, how will it contain is, a router will have only 3 layers, which means physical layer, data link layer and network layer, but then it will have something like this: physical layer, data link layer, network layer. It will have something like this. Which means it it will have two data link layers and two physical layers. The reason is simple. On one side of it router there could be one network, and on other side of the router there could be other network. For example, on one side there could be Ethernet, and on other side there could be token ring. In that case, what happens is the data link layer which is present here will understand the language of Ethernet, and it will take out the packet and send out to the other side. Therefore, this data link layer will understand how to convert the packet so that it will be read by the token ring, right? So that is why we need one more layer, network layer, along with data link layers. And at routers I have two data link layers for every interface, which means if I have three interfaces, then data link layer and physical layer will be present on this interface also. So in general, data link layer and physical layer are present on NIC, interface card, and network layer is present in the operating system. So every computer will have one network layer, and the number of data link layers and physical layers depend on the number of interfaces we have. So in this case, if I have two interfaces, then I have two data link layers, and like this. Then if a packet is going from here, from a source to destination, it will have physical layer, data link layer, network layer, transport layer, and application layer. And it will have physical layer, data link layer, network layer, transport layer, and application layer. Now the number of times a packet will hit data link layer is once here, twice, thrice, and 4 times. So a packet will hit the data link layer 4 times in this scenario if you have only one router, isn't it? So data link layer, it is hit 4 times. And what about network layer? 1 time, 2 times, and 3 times. So network layer, it is being hit 3 times. And what about transport layer? Transport layer is hit 1 time and then second time. Therefore transport layer is hit 2 times, and application layer is hit 2 times, right? Remember that. Depending on number of routers we have, the number of times every layer is hit will depend on how the packet is going on, right? So this is how, see, this is not important for gate. You know, you are not going to, no one is going to ask this entire mechanism. But if you understood everything that I told you now, I think you understood the entire computer networks. This is how the message will go on. Now, you know, you can go and see all the layers, other videos, and maybe you'll understand them better after this example, right?